Let me start the recording. And let me start out with the calendar. Okay. All right, folks, so here we are, April 22nd, right? We're going to finish up section 10.8 today on vectors. This is our last section of the course. This Friday, our plan is to just do a practice test for chapter 10. And then next week, we're just going to review a practice final exam. So here's what's coming up. Oh, go ahead.
Yeah, I have a question here. Let me think here. So this is already on week 14 already. We're on week 14.
Yeah, that's right. Next week is the last week of courses is the last week of the spring semester, right? So next Friday, May 1st, is the last day of the semester. The following week, the week of May 4th, is final exam week, right? So, folks, this Sunday on the schedule is homework 10.8 and the test on chapter 10 that's taken in WebAssign. But reminder that all the WebAssign activities are open until May 1st. So if you can't complete homework 10.8 by Sunday, April 26th, that's okay. If you can't complete the test on chapter 10 by Sunday, April 26th, that's okay, as long as you do finish them by May 1st. All right, so please remember you can go back and update and improve your scores on these homeworks. All right, folks, next Monday, April 27th, I'm going to update Canvas with all the grades from WebAssign so you can have a good sense of where you stand going into the final exam. Okay, so next Monday, April 27th, I'll update all the grades in Canvas.
I mean, and plus, like, let me think. I mean, so you're only allowed to prove homeworks then, not the previous test then.
Right, Gennaro, the tests are one attempt only.
Yeah.
So if you've already taken the test on chapter 9, let's say, you can't go back and retake it. But if you haven't yet taken the first attempt at the chapter 9 test, then it's still open for you until May 1st.
Yep.
All right, folks, let me also just mention about the final exam. So let me go to Canvas for a second. And if I go to Canvas, I'm going to go to Modules. And if I go all the way down to the bottom, notice here in Canvas, it says preparing for the final exam. This is the background information of the date and time for the final exam. Here's a practice final exam. This is what we're going to be going over next week. And here is the reference information for the final exam. So when you take the final exam, you'll get these formula sheets. Let me show you what this looks like. So this is the unit circle, all of the formulas from chapter 9, all of the formulas from chapter 10. So you don't have to memorize all of this information. You can use this handout when you're taking the final exam. Okay? If you want to print this out, you're welcome to print this out, or if you just want to bring it up on your computer when you're taking the final exam, that's okay too. All right? And then, folks, we went over this last class, but I just want to ask you to please make sure you are reserving Monday, May 4th at 10 a.m. for the final exam. Okay? if you have some kind of a conflict with May 4th at 10 a.m., please let me know that. Email me so that we can figure out some alternative.
So
The
for the
final
chapter
exam
10
has
test,
two
chapter 10 test
problems.
is wait for
Go
chapter
ahead.
10 test is only like 15 questions.
That's right. Let me get to that in a second, Gennaro. Yes. The final exam, though, is 20 questions, and you'll have 2.5 hours to complete.
Okay. So it's like a time. So it's like a time test then.
It's a timed test in WebAssign. Yes. And the way this is going to work is you're going to use your laptop or desktop to log into WebAssign to take the final exam. So the final exam is going to be in WebAssign, just like you're taking the homeworks in WebAssign. But then you're going to use your smartphone to log into Zoom, and your smartphone is going to be like the camera that's going to be monitoring your workspace, and that's just going to confirm that it's really the student taking the final, and also just ensuring that students are not getting any outside help when taking the final exam. All right, and Gennaro, on the chapter 10 test, let me go back to that for a second. Let me go to the chapter 10 test. Here is the details. Here they are, Gennaro. So it's one attempt. It'll be 2 hours, 15 problems on the tests.
Yep.
And again, this is really going to be, the chapter 10 test is really due by May 1st. But of course, if you can complete it before May 1st, that would be a good thing.
Yep.
Folks, any questions on the final exam or the schedule for the next 2 weeks? Right, so folks, please just try to get into WebAssign and catch up on any missing homeworks. And also, if you can, start reviewing for the final exam by focusing on the practice final exam that's posted in Canvas. All right, well, folks, let's go ahead then and get back into section 10.8. We have already covered some of this. And remember, our discussion now is to work with vectors. You know, and the reason we bring up vectors in Math026 is you can almost think of a vector as similar to polar coordinates, because a vector has both a magnitude and a direction, right? So you might remember that we were talking about polar coordinates, and we had, let's say, a point out here, r comma theta. Well, really, the theta part of it is giving you the direction, right? So this angle theta is giving you the direction, and r is this magnitude. And so really, when we think about vectors, it is really based on, you know, trig foundations. And also, you remember that the direction of the vector is important. So we put an arrowhead on one end of the vector to indicate the end point, and we usually put a dot on the other end to indicate the starting point, okay? Remember, this arrow doesn't mean that the vector keeps going on and on. It's just an indication of what is the end point of the vector, okay? All right, and so then we've already talked about some aspects of working with vectors. Remember, there's a way to take a vector like this blue vector and slide it into position so that it starts at the origin. We call that a standard position vector, okay? And we talked about how to do that. If you want to get the standard position vector, you just look at the XY coordinates of the starting point, the XY coordinates of the ending point, and you subtract the X coordinates. So you subtract X2 minus X1, Y2 minus Y1, that result is giving you a vector that starts at the origin like this red vector. And when you see these angle brackets, that's a special notation to tell you that the vector really did start at the origin. All right, and so we did some examples of adding two vectors together. So you remember to add two vectors, you just added the corresponding x and y coordinates. So, in this example that we did last time, you might remember to find u plus v, we really took these x coordinates and added them together. Here it was. And then we took the y coordinates and added those together. Here it is. And we ended up with the result that's a vector that represents the sum of the two vectors you started with. And then we also said, besides adding or subtracting vectors, you can also multiply a vector by a constant. So we said that you can multiply a vector here. For example, we took a vector 3, 1, and we're going to multiply it by 3. Well, all that really means is take that constant 3 and let it multiply each of the x and y components of the vector, and that gets you the multiplied vector. So if this vector v was the red vector that we started with, 3v would be this blue vector. It's really a vector that's pointing in the same direction, but it's 3 times longer. If I was to write, let's say, 0.25v, that would be taking the vector v, pointing it in the same direction, but now it would only be 1/4 as long. So this example would be, let's say, 0.25v. Okay. All right, and then I think we did some examples of just manipulating some vectors. So we did this example of just adding and subtracting vectors together.
We could try this example.
You do this one again? Let's do this one. Okay. Yeah. So in this case, they're giving us the vectors u and v. Here they are. And they want us to first figure out u plus v. Well, the way you add two vectors together is you add the x components, and then you also add the y components together. And then you put a comma in between. So let me add the x's. That would be 5 plus 8. And let me also add the y's. That's -4 plus 2. So the result of adding these two vectors together is a new vector, 13, -2. All right, how about u subtract v? Well, that's going to be the same idea, but instead of adding the x's and adding the y's, I'm going to subtract the x's and subtract the y's. So
5 minus 8, -4 minus 2.
You got it. Exactly right, Janara. So it's going to be 5 subtract 8 for the x coordinates, and -4 subtract 2 for the y components. And now this is going to be -3, -6. And the last example was asking us for 4u minus 2v.
Wait, to do that, you have to do a 4u times 5 plus 8 then.
Yeah, why don't we do this separately? Let me work out 4u down here. Well, that means just take the scalar, this number 4, and let it multiply the x and y components. So this is going to be 20, -16. And I'm also going to need 2v, so I might as well work that out separately. That's going to be 2 times the v vector, which is 8, 2. So I let this 2 multiply inside. It's almost, you can almost think of this as like a distributive law kind of setup. So this is going to be 16 comma 4. So now let me go ahead and work out 4u minus 2v. So I'm going to subtract the x components. That's going to be 20 subtract 16. And then I'm going to subtract the y components. That's negative 16 subtract 4. And when we work this out, we end up with 4 comma negative 20. All right, well, this is kind of where we left off last time. So why don't we look at some more aspects of this. And many times when you have a vector, you'd like to break it down into its horizontal and vertical components. So let me explain what this means. Let's say, and I'm going to use a vector that's in the standard position to make things easy. So let's say I have a vector that looks like this, let's say. And maybe I'll draw this as 5 comma 4. What we're going to do is break this down into a horizontal and a vertical vector. So here is the horizontal vector, and then here is the vertical vector. Notice if I travel horizontally and then vertically, I end up at the same ending point. It's just that instead of having this red vector, I'm going to instead use horizontal and vertical component to that. And you could probably see this horizontal vector is going to have length 5, and this vertical vector is going to have length 4. And you might say, well, why do you want to do this? Why do I want to take a vector and break it down into its horizontal components? Well, one reason to do this is when I'm adding many vectors together, it's going to be easier to take each vector and break it down into its horizontal and vertical components. Then I can separately add the horizontal components together and the vertical components together. So this breaking up a vector into its horizontal and vertical components is used to help combine vectors together like you might do in physics. Again, in physics, if I had multiple forces acting on, some kind of a truck, let's say, I'd want to know what is the resulting force on that truck. All right, well, here's the way we can do this. What we do is think of these vectors as horizontal and vertical, but we're going to use a special notation. We're going to use something called unit vectors. A unit vector is just a vector that has length 1. So the word unit here means a length or a magnitude of 1. And so what I can do then is I can set up a unit vector on the x-axis. So here's the x-axis, and here's the y-axis. And let's say I want to set up a unit vector going in the x direction. Here it is. It's going to be this red vector. Well, this has length 1. So if I was going to write it, I could write it as 1 comma 0. But we use a special notation for this. We call this the vector I. So the vector I is a horizontal unit vector. All it is a vector pointing in the x direction with length 1. And then we can also have a vertical unit vector. So that's just a vector that's pointing straight up, length 1. And this is going to be coordinates 0, comma 1. We call this vector j. So j is going to be a unit vector that's pointing vertically. So what this does is it allows us to take any vector and break it up into its horizontal and vertical components. So let's take a quick example on the next slide. Before I do that, let me go back one slide. I just want to point out to you that if we have a vector here, so notice in this example, they were giving us this red vector, and this red vector was at 4, 2. Well, if I was going to write this horizontal vector, I could write this as horizontally 4, vertically 0. And if I was going to write this vertical vector, this would be going vertically 2. So I can take this vector 4, 2 and break it up into these blue vectors. Let me draw this in blue. This is a blue horizontal vector, and this is a blue vertical vector. And you could probably see if I was to add these two vectors together, it would get me the resulting vector 4, 2. And I could write it this way. But instead of writing it this way, we're going to use the IJ notation. It's just more common to write it using this IJ terminology that references the unit vectors. Okay, so let's do that. So here's that example we were just looking at. Whoops. Here's this example we were just looking at where we have this vector 4, 2. Let me draw this in red just to make it consistent with. Here's the vector 4, 2. And we could write it as we just did on a previous slide, but instead we're going to write it like this. This vector can be rewritten as 4i plus 2j. What does that mean? Well, remember the unit vector I is a horizontal vector of length 1. But if I was to write 4i, that would be kind of like putting 4 of these vectors, right? 4 of these horizontal vectors. So 4i is really a horizontal vector that's length 4. Remember, each unit vector has length 1, but I'm multiplying it by the scalar. So that means 4i is going to have length 4. And then 2j is a vertical vector of length 2. Okay, so it's easy to take a vector and rewrite it in this ij notation, because all you do is put the x coordinate in front of I and put the j coordinate, put the y coordinate in front of j. All right, let me give you another example. What if we had the vector u as -7, 15? And you were asked to rewrite this using the unit vectors I and j. Well, this would just be -7i plus 15j. Right, so it's just another way to write the exact same vector using this ij notation. Again, the reason you might want to do this is it's going to make it easier later on to combine vectors together or to do other vector analysis when the vectors are written in this ij unit vector notation. Okay. All right, well, what if you have a vector that's not in standard position? So let's say I have a vector that's, let me do that. Let's say I have a vector that's not starting at the origin, but it starts out here. And let's say this is x1, y1, and x2, y2. And I want to be able to write this in ij notation. So notice it says up here, if you have a vector v, let's call this vector v, that has initial point P and terminal point Q. So let me call this point P, call this point Q. The way you can write it is V equals x sub 2 minus x sub 1 times the I vector plus y sub 2 minus y sub 1 times the j vector. By the way, folks, I noticed there's a typo here. So let me circle in purple a typo I just see right here. That parenthesis should be y sub 2 minus y sub 1. Okay. And when you do this, you're going to end up with a vector, and sometimes we write it as AI plus BJ just to indicate the coefficients of the I and j vector. All right, let me show you an example of setting this up. Let's take a look at this one. It says, let's say you have a vector that has a starting point P and a terminal point Q. Write the vector in terms of I and j. Okay. Well, the first thing I'm going to do is label these points so I don't get confused. Now, remember, we always label the terminal point or the end point as x sub 2, y sub 2. And I'm going to label the starting point as x sub 1, y sub 1. Now, I'm just going to plug into this formula. Looks like they did write it correctly here as y sub 2 minus y sub 1. So in our example, I'm going to take x sub 2, which is negative 6, and subtract x sub 1, which is 2. That result is going to multiply I, plus, now let me take y sub 2, which is 6, minus y sub 1, which is a negative 6. And that result is going to multiply j. So this is going to be negative 8i plus 12j. By the way, folks, I and j here are vectors. So keep in mind that I and j are vectors. So what that means is when you write I and j, usually we'll write them either as bolded. So we would write I in boldface, or sometimes you would see I with an arrowhead on top. Now, if you're going to enter these answers in WebAssign, you can't just type in the letter I from your keyboard, because you have to tell WebAssign that you really mean the vector I, not the letter I, but the vector I. So what you have to do is go over to the Math menu in WebAssign, and there's going to be a Vectors menu, and you'll see I and J as characters you can select to put into your answer. Okay? All right, folks, there's one other item I want to mention to you. Because if I was to graph this vector, let me graph this vector. Sometimes we want to know the magnitude of the vector.
Okay.
So if I was going to graph this vector, it's negative 8i, so that would be going this way, plus 12j, which would be going up. So our vector, I'll draw it in red, looks like this. But sometimes you're also interested to know the magnitude of the vector. You could think of that as the length of the vector. Well, you might notice to figure out the magnitude is actually a Pythagorean theorem kind of question. Because this side is 8, this side is 12, and this side is C, the hypotenuse of the right triangle. So if I want to find the magnitude, I just use Pythagorean theorem. So in this example, the magnitude squared, or let me use C, just to make it consistent with my diagram here. So let me write this as C squared equals 8 squared plus 12 squared. Right, and of course this would be 64 plus 144. This would be C squared, and so C squared would be, I think that's 208. And then C is the square root of 208. So the magnitude of this vector, I'll just work this out on my calculator as a decimal approximation.
Is that the Pythagorean theorem?
Exactly right. Yeah, Gennaro, this is really a right triangle. So when I think about finding this length C,
Let me just write everything down real quick before you go ahead.
Think of this side as A, this side is B. So I'm kind of back to using the old C squared equals A squared plus B squared. So this magnitude is about 14.4 on my calculator. Let me go back to the previous slide because I just want to show you on the previous slide the magnitude was mentioned. So if I come back here, notice it says when you want to know the magnitude of a vector, we use this notation to mean the magnitude. So when you see these bars, it means you're finding the magnitude of the vector. Okay. And in this case, notice they're giving me the square root of A squared plus B squared. Again, that makes sense because I'm thinking of this side C as the magnitude. This length would be A, this length would be B, and this is a right triangle. So this formula is really nothing more than Pythagorean theorem. Okay? So in our example, we had the vector V equals negative 8I plus 12J, right? So sometimes you see this written as AI plus BJ. So in our example, A would match up to negative 8 and B would match up to 12. And then what this formula is telling you, if you want the magnitude of the vector, take the square root of A squared plus B squared. And in our example, that was just the square root of negative 8 squared plus 12 squared, which of course is what we just worked out a minute ago. This is the square root of 8, which we said was about 14.4. All right, so finding the magnitude of these vectors really is kind of going back to Pythagorean theorem, and essentially you're finding the length of the hypotenuse of a right triangle.
Wait, hold on. Go back real quick. I didn't finish writing.
Okay. Sorry, Janelle. Yeah.
It's fine.
And folks, just a reminder, remember these online classes are being recorded. So if you ever want to go back and watch the recording, you are welcome to do that. All right, folks, why don't we go to a web sign example?
I finished everything over there.
Got it? Okay, good. All right. Here's a web sign example. And they're asking us to come up with the vector V, but it's got to be an I and J notation. And they're giving us the starting point, they're calling it P1, and the ending point, they're calling it P2. And they want us to come up with the vector V in terms of I and J. Well, the first thing I'm going to do is label these points. Remember, the starting point is always labeled as x sub 1, y sub 1. And the ending point is always labeled as x sub 2, y sub 2. All right, folks, be careful with this labeling. You know, this is a different calculation than slope. You might remember back in algebra, you calculated the slope of a line between 2 points. For the slope calculation, it didn't matter how you labeled x1, y1, and x2, y2. But this is not slope we're talking about. This is different than slope. So the order here does matter. So you always want to label x1, y1 as the starting or the initial point, and x2, y2 as the ending or terminal point. All right, well, now I'm just going to plug into this formula that's on the bottom of the slide to find the vector v written in IJ notation. Again, I'm seeing a typo here, folks. This parenthesis, let me circle this in purple so you can see it. This parenthesis should be in this parenthesis right here, should be y sub 2 minus y sub 1. All right, I got to fix that in the slides. My apology for that typo. All right,
So that's
let me
the one
write.
that we're going to be using then.
Yeah, let me write this out, and we're going to plug in. So I'm just copying the formula here.
Actually, should be a y2 minus y1. Here it says right there.
Exactly right, Janara. Yeah, it's got to be y2 minus y1 is the correct way to write it. All right, let me plug in. Our x sub 2 number was -9. So this is going to be -9, subtract the x1 number, which was 2. That multiplies the I unit vector. Then I'm going to grab y2, which was a +9, subtract y1, which was a +7, and that's going to be multiplying j. All right, well, this turns out to be -11i plus
Then 2j.
2j. Good. Now, let me point out something in the answer. Do you notice in this green answer box, notice the way I and j are bolded? Can you see that here? The letter I and j are bolded. It's not just typing in I and j from your keyboard. So you have to go over to the math menu in WebAssign and go under vectors. There's a menu for vector notation, and you'll see a button for I and a button for j. You've got to use those buttons to enter your answer. Otherwise, WebAssign might not accept it. Okay? All right, well, also they're asking me to graph this vector. So another part of this WebAssign question says, which is the correct vector on the graph? Well, all I have to do is recognize that the starting point is 2, 7. Let me draw my own little graph down here. Maybe that's going to be easier. I'm going to draw my own graph down here. So the starting point is 2, 7. 2, 7. There's the starting point. The ending point is -9, 9. Well, -9, 9, let's say here's -9, and here's +9. -9, 9 is back up here somewhere. And remember, this is the starting point, and this is the ending point. So my vector has to look like this with an arrowhead pointing to the end. So the only graph that matches that is this upper left-hand corner here. So this is the correct graph. Notice this upper right-hand corner is wrong. And the reason it's wrong is they have the arrowhead on the wrong end. Right? They're putting the arrowhead on the starting point, but the arrowhead always has to be on the ending point, which is why the arrowhead has to be over here. All right, folks, let's just do a couple more quick examples here. You know, the nice thing about adding vectors when you have them written in this IJ notation is it's like adding vectors now is kind of like combining like terms. Let me give you an example of what I mean. Let's go to this example here. It says vector V1 is 2I minus 3j, and vector V2 is 4I plus 5j. Well, let me form V1 plus V2. I'm going to add these two vectors together. We can almost think of it as like combining like terms. So let me take 2I plus 4I. That's 6I. And then I'm going to take negative 3j plus 5j. Well, that's 2j. So adding these vectors are now very easy because you're just adding the I components together and the j components separately. It's almost like, you know, adding x's and y's together, adding like terms together.
Wait, actually, the formula we just did for 2i, and that's the example we're doing.
Yeah, let's go do an example, Gennaro. Let me go to a WebAssign example. First, let me just mention this. If you're multiplying a vector times a scalar, remember that means you're multiplying the vector times a number, and you have the vector in IJ notation. Again, this makes it very easy because all you're going to do is multiply. So here they're giving us this example. V is 3I plus 7j, and they're asking us to calculate 5v. Well, you can almost think of it as 5 multiplying this vector 3I plus 7j. Well, this definitely looks like the distributive property, right? So I'm just going to multiply the 5 inside. So that's going to be 15I plus 35j. Okay. So again, another advantage to writing in this IJ notation is it makes this, you know, working with vectors kind of similar to algebra, like combining like terms or multiplying using a distributive property, and it just makes the analysis a lot easier. All right, let's go and do a quick example here from WebAssign. And so here they're giving us a vector u and v. By the way, folks, I just want to point out, can you notice how these vectors are all in this bold notation? Notice that u, and I, and j, and v, these are all bolded because they're all vectors. So they're in bold.
Let's go.
All right, well, let's work out 3v plus 2u. Okay. Well, for that, all I have to do is take the v vector. Now, folks, you got to be a little careful. They're giving us v first and u second. So just be careful to grab the correct vector. So this is going to be 3 times the v vector, which is negative 5a minus 8j, plus 2 times the u vector, which is going to be the vector I plus 9j. Right? Everyone agree this is vector v here, and this is vector u here. All right, now this is going to be pretty easy because this is almost like an algebra problem. Let me multiply the 3 inside the parentheses.
Negative 24j, then plus 2i, plus 18j.
Yep. Now, Gennaro, you might be doing your example, which is slightly different than ours.
Actually, I'm just doing the same example as you, as I see on the screen.
Okay. So do you agree for this first parenthesis, 3 multiplies negative 5, so that's going to give us negative 15i. Then the 3 is going to multiply this negative 8, that's minus 24j. Now let me take this 2, and it's going to multiply inside the parenthesis.
Now we have to do combine like terms. I have to do now.
You got it. Combine like terms now. So I have a negative 15i.
Be negative 13i.
2i. So that's negative 13i.
Plus 6.
Yep, a negative 24j and a plus
minus
1
6.
minus 6j. Good. And that's the answer. But again, remember that when you go to enter the answer in WebAssign, you need I and j to be entered as vectors.
Not like the normal I and J.
Not just the letters I and j from your keyboard.
I mean, I tried that before. It didn't work.
Exactly right, Janara. Yeah, thanks for mentioning that. If you use the letters I and j from your keyboard, WebAssign will mark it wrong. So for I and j, you must go to the math menu in WebAssign. All right, folks, let's talk about one last item for today. And the one last item is finding what's called a unit vector. And we've already mentioned a unit vector has a magnitude of 1, but we want to take any arbitrary vector and come up with a unit vector. Let me give you an example of what I mean. Let's say I have a vector going like this. Well, I'd like to be able to find a unit vector that's in the exact same direction, except it has length 1. You know, maybe this length of the red vector is length 17, let's say. But I want to come up with a unit vector. The unit vector, let me just write this in blue. The unit vector would look like this. It'd be in exactly the same direction, but it would have a length of 1. So this blue vector is the unit vector. So how do we find a unit vector? All right, here's what you do. If you want to find a unit vector, you've got to take the original vector and divide it by its magnitude. So this on top of this fraction is the original vector you started with. And on the bottom of the fraction, you're going to divide by the magnitude of the vector. Now remember, the magnitude you calculate by using Pythagorean theorem. Let me do an example to show you what this is asking you to do. Let me go to an example. All right, here's an example. It says, find a unit vector in the same direction as the vector negative 5, 12. Okay, so they're giving us this vector, negative 5, 12. Let me draw that just so we can kind of see where it is. Negative 5, 12 would mean go over here, negative 5 and up 12. So this red vector is the vector they're talking about. But I want to find the unit vector. I'm going to draw it in purple. The unit vector would be a vector pointing in the same direction, but it has to have magnitude 1. All right, well, here's the way you do it. To find the unit vector, you take the original vector and divide it by its magnitude. All right, let me find the magnitude to begin with. By the way, you know, I could write this vector if I wanted to as negative 5i plus 12j. So I can either write the starting vector in angle brackets as negative 5, 12, or I could write it as negative 5i plus 12j. Let me find the magnitude. Well, for the magnitude, I'm going to take the square root of negative 5 squared plus 12 squared. Again, I could see that from this right triangle, because this hypotenuse is really the magnitude I'm after. So this is going to be the square root of 25 plus 144, which is the square root of 169, which happens to be 13. So the magnitude of this vector is 13. All right, so let's go ahead and figure out the unit vector that we're after. I'm going to write this as negative 5i plus 12j, because that's the original vector to start with. But then on the bottom of the fraction, I want to put the magnitude. Well, in our example, the magnitude was 13. So this is the answer. This is the unit vector that is in the same direction as the starting vector, but it has length 1. I could rewrite this if I wanted to break this up into 2 fractions. I could write this as negative 5i over 13 plus 12j over 13. So either one of these answers is equivalent. Okay?
Well, so it doesn't matter how you write the answer then.
Yeah, either way is equally correct, Janara. It's up to you. WebAssign should take either answer. All right, folks. Tell you what, we're out of time. So why don't we do this on Friday? Let's do this example. Let's do this on Friday. And maybe before Friday, you can work it out yourself. And the way you're going to come up with the unit vector here is take the original vector A and divide it by the magnitude of A. But let me let you try this. And we'll do this as the first example for Friday's class. All right, folks, any questions here, folks, on section 10.8? So, folks, on Friday, we'll do this example on this slide, but also we'll do the practice test for chapter 10. So if you have a chance to look that over before Friday, please do that. And folks, if you have no questions, feel free to log off. Thank you for joining. If you do have any questions, stick around and I'll be glad to help out. And then hope you can join on Friday. Okay. All right. Thanks, everyone.